So next we have Mohit. So Mohit, go set it up. I'll put it down. Put it up in there. So here we have Mohit. Let me welcome him. Let me take all my stuff from here. So Mohit is a co-chair of LWIG and EMU working group. So he's a true success story when it comes to like how to get chairs positioned in ITF. It's not just for graybeards, and here I was waiting for my beard to go gray. I'm getting a few, but that's not always true. So we are very happy to have him here. He'll be talking about IoT bootstrapping. Again, the same topic kind of continue, but focusing on EAP and NOOB. So all set? Here's to Mohit. So connect the, you need the clicker, right? So connect this thing. Here.
Hi, I'm Mohit. Let's first have a round of applause for the organizers, Dhruv, Vinayak, Nalini. They saved the best IoT presentation for the last. So yeah, thanks for the introduction. I'll again briefly tell who I am. So I'm Mohit. I work for Ericsson Research in Finland since January 2012. I'm also unique in a way that I'm affiliated with the academia. So I'm also a postdoctoral research fellow at Aalto University since May last year. In the past, I've been a visiting researcher at Carnegie Mellon in the US. I have a Doctor of Science degree, so I'm not a philosopher. I don't have a PhD. I'm a Doctor of Science. And the title of my thesis was Security for Ubiquitous Internet Connected Smart Objects. I also have a dual master's degree from Sweden and Finland. So this was a European Union funded master's program where they pay your tuition fee, your living expenses. So I studied a year in Sweden and 1 year in Finland. So that's all nice. You have some fancy titles, but what do you do in practice? So maybe my friends, when I say that I'm a researcher, think that I wear a lab coat and sit in a lab and play around with some chemicals. Of course, my family would like to believe that I'm working on the next Nobel Prize. I'm sure there are some people in the society who look down on the academia as wasting taxpayers' money on publishing papers that no one reads. Some colleagues in the industry think that research is working on something that is 10 to 20 years down the line and has nothing to do with reality. That's not really the case. Of course, what I think I do is this scholarly person who goes around enlightening the next generation, but in practice, I'm doing a bit of all of them. So enough of jokes. What do I do in reality? I work on applied network security. So I work in the industry. It has to be applied. It's not very theoretical. The timeline is generally 2 to 5 years down the line. So we are working on things that we plan to see in the market 2 to 5 years down the line. And research is something like throwing sand at the wall. You try out many different things and then you see what sticks on the wall. A lot of people, when I say I have a PhD or I have a Doctor of Science degree and I'm a researcher, think that I don't write code. I'm this guy who writes a lot of papers. That's really not the case. I think for many of the people these days, they do hands-on coding. And there's a big difference between writing a JavaScript HTML page and actually writing hands-on code for standards. So I would take a pause here and show why it's important to actually write code for standards you want to push in different standards organizations, because until you have written code and not just one prototype in your lab, but until you have written several different implementations, you don't actually get to iron out all the errors in your specifications. I'll show you a couple of examples of current standards, some which are being developed, some which are already published, and what kind of errors they still have. So this is something I haven't pointed out to them yet. Let me show you. So this is IETF draft. that is working group adopted. So it's currently being worked on in the IETF and eventually will be published as RFC since it's already working group adopted. And I wanted to show you here. You don't have to know what this draft does because that's irrelevant. I just wanted to show you what are some of the mistakes that this draft makes and why you need to implement code to not make the same mistake. So here, I hope you can see at the back as well. Here it says something is encoded with base 64 URL. That's the first part of the token. So there's some error here. Does anybody want to take a guess? What's that? Go ahead, Elliot.
I'm just guessing. It doesn't need to be encoded in base 64.
That's true, but you could encode it in anything you want. Anyone else who wants to give it a try? They get free lunch. Well, maybe the first smaller thing here is that it doesn't have any reference to what is base 64 URL encoding. Should I go on Wikipedia to look it up what it means, or should I go to some RFC? Is it ISO standard? How do I even know what is base 64 URL? Until I know that, we can't have the same implementation. So of course, as a consensus engineer, you will go to Google, probably look at some Stack Overflow code, and then you will finally find that this is the RFC that defines base 64 URL encoding. So let me go up a little bit. So here you see this is the RFC defined in 2006, which tells you how to encode data in base 16, 32, 64. And somewhere in this RFC, it also talks about base 64 URL. So let's look here. Let's read these lines carefully. So the pad character equal to is typically percent encoded when used in URI, but if the data length is known implicitly, this can be avoided by skipping the padding. So this means that I could skip the padding or I could keep it. And this is where implementations run into problems. So Python libraries actually keep the padding with the equal to. But C, most of the C code on Stack Overflow that you will probably copy paste into your own code doesn't keep this padding because data length is implicitly known and you want to avoid buffer overflow, so you want to hard code exactly the amount of data you are copying. And we actually implemented base 64 URL encoding for our own specification that we are working on. And we had 2 implementations, and we did run into this exact same problem because we are using this encoding to create some hash, and of course the hashes don't match because one implementation has the padding and the other doesn't. So I'll show you another example where this is. So this is a published standard, and you heard about this device provisioning protocol from Elliot and Michael. I don't care whether it will be successful or not, but this is open standard, so you can go and download this. Here again you see JWS compact serialization is a base 64 URL encoding of. So, yeah, again this is a published standard, and they don't seem to mention whether base 64 URL is with the padding or without the padding. I'll talk about my draft EAP NOOB a bit later, but I just wanted to show you, since we have done the implementation and we know what kind of errors you run into, this is how we write the text in our draft. 16-byte identifier that is base 64 URL encoded without padding. So you have to be precise to the last byte, otherwise your implementations can never interoperate. And this is what I mean by writing code. It's not just creating some HTML 5 pages, which is also good. You should do that. So any code that you write is good, but there is a big difference between writing code in products and writing prototypes in your lab. Yep, that's fine. So yeah, so I covered the coding part. That's very important. But of course, I'm also an academic researcher, so no research is complete until you have actually proven it to be complete, and that's where you do formal modeling. So a lot of people who have never done formal modeling think of it as something you write a specification, you give it to some student in the university who writes the formal model, and the output is hence proved it's secure, or hence proved it works. In reality, that's not the case. You actually actively need to work on the model to make sure it's modeling the protocol correctly, to make sure it's actually doing what you had written in the specification, and then you find some errors or bugs. These could be security bugs, but more often than not, these are actually bugs in state machines. So I'll show you one example of formal modeling where it can help. So let me go on to the next. This is not your DNA. This is not a class on biology, but this is actually a model of a client and server protocol. So what it is doing is it's modeling all the possible states that a client and server can be in and how the protocol can proceed. So it starts when both client and server are in state 0, and then your protocol runs, and then you move to state 1, then you move to state 2, then you move to state 3, and then it keeps on going until you limit it. Of course, you need to limit the server resources to stop the formal modeling process at some point. And what kind of errors you can find with this kind of modeling is here is a trace between a client and a server. They were initially in state 1, then the client sends a packet to the server saying that I have moved to state 2. The server gladly moves to the next state and sends an acknowledgement back to the client, and both of them are now in state 2. But what happens if one side moves to the next state while the other stays in the same state? So imagine if your network did not have reliability, even if you run it over TCP, even if your link layer implements fragmentation and reassembly, if I'm a determined attacker, I can always drop packets selectively. So what this does is basically this model can show you that there is no way to recover from a condition where the server is in a different state from the client. And if you had not built your specification to recover from scenarios like this where two entities end up in different states, well, too bad, neither will your code implement any recovery mechanisms, and basically you will hang up, and this is why we often have to reset our devices, because most of the things have not been formally modeled for finding issues like these. So we looked at two different things, why coding is important, why formal modeling is important. Before I move on, these days if you do anything in security, it's becoming kind of a bar that you need to have a formal model proving its security, without which accepting new protocols in the IETF is getting harder. So if you have some new security ideas and you want to push them, I would definitely recommend you to do thorough formal modeling, and TLS 1.3 is a perfect example of this, which has gone through many iterations of modeling, and the protocol has changed. In fact, the IETF made changes based on the protocol modeling results, so it is very relevant and important. Of course, Dhruv already mentioned, so in addition to those, I do security standardization at the IETF. I don't have large number of RFCs to show, but I don't get any bonus for publishing a RFC. I only do work when it makes sense. At least that's the case for me. Of course, I work in the university, so I also publish papers. Not that many, but every now and then, and we have a couple of best paper awards. Finally, I work in an industrial company, so we also do patents, and before any of you come running to the mic that we believe in open source and open everything, I can proudly say that none of the work that I do at the IETF is covered by any patents, which maybe not all the speakers here can say about themselves. So you would ask then, how do I have these 50 patents if none of them cover the work that I do at the IETF? Well, I work for a mobile telephony company which is active in 3GPP, and 3GPP is a standards organization that works on patents. So most of my patents are work that I do on 3GPP and have nothing to do with IETF. All right, so now that I spent maybe 20 minutes describing what I do, it's time to actually move to the technical part of my talk. I'm sure by now you already know what is Internet of Things. I'm not going to define it. I'm just going to say that there is a ton of buzzwords that you might hear that all refer to the same phenomena. So for some people, IoT is the small temperature sensor, but even your phone is IoT, and even your fridge is IoT, and anything that's connected is IoT in that sense, and you can call it pervasive computing, ambient computing, ubiquitous computing, smart home, smart city, smart whatever you want to call it. So let's have a look at a real life example of IoT. I'm not going to spend more time on defining IoT, but rather showing you an example of IoT.
Welcome to the Edge. This is certifiably the greenest office building in the world. But that just might be the least interesting part about it, because the Edge in Amsterdam is also possibly the most connected office space in the world. Working at the Edge is insane. It all starts with a smartphone app developed by the building's main tenant, the consulting firm Deloitte. When you arrive at the Edge, a camera recognizes you by your license plate for automatic access. And because it's the Netherlands, there are chargers available for electric cars. Inside, things start to get interesting, because you don't have a desk. No one here does. Workspaces are assigned to you based on your schedule for the day. You have options: a work booth, a meeting room, what they call a concentration room, a sitting desk, a standing desk, a balcony desk. You can even just hang out in the sun-filled atrium all day. This concept is called hot desking, and it's what allows Deloitte to have 2,500 workers, but less than half as many desks at its Dutch headquarters. The app knows your preferences, and when you arrive at your workspace, the lights dim or brighten based on your stored settings. And any of the building's massive flat screens can be instantly paired with an iPhone or a laptop. So what makes all this possible? The LED light panels developed by Philips specifically for the Edge are actually powered by low-voltage Ethernet cables, which means every light in the building becomes its own internet-connected data hub with 28,000 sensors that makes the building and its users smarter.
The building.
All right, so maybe the important thing I wanted to highlight here about the Philips light was that they specifically built it for this building. It wasn't that someone just went to the shop and bought a bunch of Philips light bulbs. These were specifically built for the Edge. By the way, it's an actual building in Amsterdam. It's not there in the future. It already exists right now. So maybe what I wanted to highlight was that in this deployment, you have expert installation. It's not like you and me as a user are going and installing these connected light bulbs, but some experts are installing it because it involves wiring and things like that. It's also a very planned deployment. It's not like I bought 10 bulbs today and 20 bulbs tomorrow. These were planned when the building itself was planned, and there was a complete thought process into this deployment. And as the video said, that Philips specifically designed this solution for the Edge. So these are very pre-configured and customized solutions, and these are very different from these kind of IoT devices. So this is what my talk is going to look at, is actually these kind of IoT devices that you purchase, let's say from Amazon or Flipkart or one of these websites, or you go to an electronic store and you buy these devices. So here on the top left, we have a baby monitoring camera that you may use to remotely monitor what's going on at your home. On the right is the Ring doorbell, which is again a Wi-Fi connected doorbell that allows you to see who's at your door. Funny enough, this company was acquired by Amazon for $1 billion. And then of course you have Amazon Echo, you have the Nest thermostat, Chromecast, you have Wi-Fi connected printers, and on the bottom left you have something called Amazon Dash button. This is something pretty interesting. So basically you can program this button to buy anything on Amazon. So anytime you run out of, let's say washing detergent, you press a button and it arrives at your home. You don't even have to go online to their website and put anything in your shopping cart. Again, it's connected to your home's Wi-Fi, and all you need to do is press a button and things will show up at your door. So how these deployments are different from the Philips light bulbs in the Edge. So these deployments are not planned. I mean, I go to the shop and I buy a couple of devices today, and then maybe I go a year later and buy maybe Wi-Fi connected speakers, and then few years down the line I may decide to upgrade and get a new smart TV. But these are not like devices that I bought in one go. And the security configuration problem here, as probably Elliot and Michael already pointed out, is that you need to configure these devices, and configuration involves at least two things. So first you need to make sure that they connect to the Wi-Fi network. So typically this requires you to input the SSID and password. And of course, as you might have noticed, these devices don't come with a keyboard. So how do I enter the SSID and password? But that's not it. You also need to associate these devices with some sort of a user account on the cloud. So if it's Amazon Echo or Amazon Dash button, you associate it with your Amazon account online. And if it's a Nest thermostat, you associate that with your online service. And similarly for most of these Wi-Fi appliances, they come with some sort of a cloud service where you have a user account. So you need to do this step twice. You first enter the SSID and password so that the device can get internet connectivity, and once it has internet connectivity, you still need to enter your username and password so that it can connect to the cloud. And imagine doing that for one device, and if you have to do it for 5 to 10 devices, it gets pretty tedious. That's not enough. As your home networks start to scale and as you add more and more devices, you would want to know, is some of my devices misbehaving? Is it connecting to some server in Taiwan that it should not connect to? And of course, how do I perform software updates on these devices? I don't want my toaster to update in the middle of the night. So those were the configuration problems, and what challenges we have. Well, these products will not only be used by you and me who have computer science degrees, but also by others who are not non-expert users. Scalability is a problem. So currently how Wi-Fi PSK or Wi-Fi Home works is all your devices have the same passphrase. And that's fine if you have, a couple of MacBooks and an iPad and a couple of laptops, but imagine once you start having hundreds of devices or at least tens of devices in your home network, and all of them share the same passphrase, and if one device gets compromised, your whole network gets compromised. Not even that, think how would you change the Wi-Fi password on all your devices? So imagine I come to your home and I'm very kind person, and I say, could you give me your Wi-Fi password? I want to connect to the internet. And you help me, you give me the password, and I use it for a couple of hours. Then I go away, and you know that I'm a security person, so you are paranoid, and you now want to change your Wi-Fi password. Imagine now that you have to go and change it on your printer, on your thermostat, on your Wi-Fi doorbell, all of those devices. So that becomes a problem. Of course, we already mentioned that these devices don't have keyboards, so user interface is a challenge. Lastly, I think someone on the mic asked this very important question: what happens when the manufacturer runs out of business? Because these are not just manufacturers like Nest and Amazon, who we can assume to be around for 5 to 10 years, but many of these devices are purchased from things like Kickstarter, Indiegogo, and these kind of campaign websites where 6 months later the startup is out of business. And if you cannot ever use your device without the manufacturer, that's maybe a big question. Are you going to then buy these devices, and what happens when you have tens of devices with no manufacturer support left? I would especially mention Revolve Smart Hub as an example. So this is a smart hub that was being sold. It was acquired by its competitor, Nest, and then they decided to stop supporting it. So that's one way to kill competition, is you acquire that company and then you stop supporting it. And all those people who had this smart hub cannot use it anymore. So it's a very real problem that we have. It's not just theoretical. What happens if manufacturer runs out of business or ceases to exist? It has already happened now. So our solution is to do something like 802.1x enterprise security even for home networks. Of course, it's a big challenge because home users already find using a same passphrase on all their devices challenging. Doing 802.1x would be even more challenging, but that's a problem that we as engineers and researchers need to solve. But 802.1x gives you many benefits, even in home networks, that it allows you to have allows each device to have its own credentials. How many of you know how does 802.1x EAP work? Okay, so I'll go through how does 802.1x enterprise security work, and how does it compare with security that you're used to, which is the same passphrase on all the devices. So I'll spend maybe 5 minutes on giving you a brief tutorial on how does 802.1x enterprise security work. If nothing else, at least you will learn what's the difference between this and shared passphrase. So one major design decision in 802.1x enterprise security is that you don't want to do security on your router. You actually want to centralize security onto a server, which is called a AAA server. You don't want to have your same keys in your devices and the routers. Instead, you want to have different keys for all your devices on a centralized server, because it gives you more malleability and it gives you more opportunities to configure and run your network. So now let's say you have these access points, and the access points now need to trust the server. So what's happening here is that the access points are no longer authenticating the devices themselves. They instead rely on this server, and this centralized server will authenticate your devices and then tell the access point, yes, it is a trusted device, let it join the network, or no, this is not a trusted device, don't let it join the network. But the idea is to centralize the security as much as possible, because it improves certain aspects rather than having the same passphrase in all the 3 access points and then all the hundreds of devices you have. So let's see how you would use this server and access point for authenticating a new laptop. So this laptop comes onto the network and says, hey, I need to connect to the internet. And you're of course like, I don't know you. Who are you? Give me an identity. And you as the laptop say that my identity is, let's say, my ID at ietf.com. And so far you are not allowed to connect anywhere, but now that you provided an identity that the access point sees, it asks the server, should I allow this onto the network? Should I allow this guy who calls himself my ID, sorry, it should be ietf.com. And then you run the server and the device run a couple of request response messages, and they try to authenticate to each other. And then when this authentication is successful, the server will tell the access point that yes, you are allowed to connect to the internet. Let this device allow it to connect to the network and allow it to connect to the internet. So this is how it works. And you might be wondering that, wait a minute, this device did not have any internet connectivity. How did it even connect to this server? How was it able to exchange this request response messages that you see? This is how 802.1x works, that it allows you to temporarily connect to a server and prove your identity, and then you can connect to the rest of the internet. So if I have to give you an analogy, think that you are at the airport and you want to use Wi-Fi, but you have to pay for it. So what the Wi-Fi would do, it would allow you to connect to your credit card vendor, which could be MasterCard, Visa, or something, to make the payment. Once you have made this payment, you would be allowed to connect to the rest of the internet. So it's this small moment when you're allowed to talk to a server. Once the server authenticates, then you can talk to the rest of the internet. So of course there are many other acronyms involved, so it's not as simple as I have made it in this picture. On the left hand side, the protocol that is used between the access point and the server is called radius. Of course you could use something newer that is called diameter. And on the right hand side, the messages are sent on something that's called EAP, which is the Extensible Authentication Protocol. EAP is a very good example of a framework that actually works in practice, because I have seen so many frameworks and architectures that are extensible but are never extended. EAP is probably the only exception where you have more than 50 authentication methods. So EAP is kind of a framework that allows you to use any authentication method you want. If it's certificates, you can use EAP TLS. If you have a SIM card, of course, you can use EAP SIM. If you have some other forms of credentials, you can already use EAP for authenticating. So I hope with this you have some more idea of how does 802.1x enterprise security work. So now coming to actually what I'm working on, or I used to work on, it's more or less done from our side, is EAP NOOB. It's extensible authentication protocol, and the method is called nimble out-of-band authentication. So pardon me for the acronym, but noob in English also means someone who is not an expert. So there was a little word play here, and the reason for naming this is that this protocol is meant for configuring devices even for non-expert users. And the problem I already showed you, that you have these Wi-Fi connected printers and Nest thermostats and those kind of things. How do you configure them to connect to the Wi-Fi? But not only that, how do you configure them to connect to the cloud? So you need to do two things. When you have a new device, you need to connect it to the network, and you need to register the device on the server. And EAP NOOB does both, and it only requires you to a single user-assisted out-of-band message. So I'll come to that. What is user-assisted out-of-band message? So instead of going into the protocol details first, let's look at the user experience we want, and I will take the example of a smart TV that you have just bought and you want to configure. So this is the use case we actually want to have. You go to the shop, or you order it on Flipkart, and a new display comes. You hang it on the wall, you connect it to power, and you press the power button. So now once you press the power button, the display will start scanning for all the networks that it sees around you. It will run this new protocol in the background, and it will generate a dynamic QR code based on the networks that it sees. So one important fact here to note is it's not a static printed QR code that came on the TV. This was generated when you switched on the TV and it scanned the network. So it will be different when you switch on the TV at your home and generate this QR code, and it will be different when I do that at my home, because of course the networks that the TV would see would differ. So now that the TV has generated this QR code, the user scans this QR code. The QR code is actually a standard URL, so it will open the web browser on your phone. And you're already used to signing into cloud services with username and password on your phone. So all you need to do now is to simply do your account login as you already do. And by doing this, your display is not only connected to the cloud, but it's also connected to the internet. So the idea here is that with one step, you got two connectivities, one to the internet and then to the cloud. And this display is now associated with the user's account on the cloud. You might be wondering, how does this work? But the idea was to show the user experience we want to target. And of course, this all looks very nice in PowerPoint, and you will ask, does it actually work? Well, we have running code. So I'll try to show you a demo video of configuring a smart TV. So here you see my Linux TV is scanning for the different Wi-Fi networks that it sees. And based on this information, it will try to generate a QR code and show it in the browser. So now the TV has scanned all the networks. It shows you a QR code. On the phone, you scan this QR code. It opens a URL. Well, anyways, you've got the idea that just by scanning the QR code on the TV, you got connectivity both to the cloud and to the Wi-Fi network. All right, so we are back online. So now comes the more dirty technical details. It's okay if you don't understand some parts of it and you want to check your email, but I would of course be happy if you continue listening. So the idea here is that you have these Wi-Fi connected appliances like printers, TVs, cameras, that you want to connect to the cloud and to the internet at the same time. So they run this new EAP method which we have defined called EAP NOOB. And the in-band message, so again coming to this, what is an in-band message and what is an out-of-band message. So in-band is something that you cannot see. So if there are packets going on the wireless interface that you cannot see, or if it's going over the Ethernet cable, if you cannot see it, that's in-band. And out-of-band is something that you can touch, feel, or see. So if it's a QR code that you can see and you are scanning it, that's out-of-band message. If it's NFC, that's out-of-band. If it's audio that you can listen, that's again out-of-band. But if it's packets going on the network, that's in-band. So it runs this new EAP method over the wireless interface. It does some protocol details that I will go into on the next slide. But the idea is that based on this, it will show you a QR code, or now you would wonder how would a printer show a QR code? It doesn't have a display. Well, it has paper to print QR codes on, so it would print the QR code on the paper. And of course, if it's a camera, you cannot show a QR code on a camera, but instead you can generate a QR code on the server and show it to the camera. And this is where the other part comes in, this out-of-band message that actually associates the device to your user account on the cloud. So the idea is that you run something on the in-band and then the user confirms the security using this out-of-band message, which could be QR codes, NFC, audio, but anything that you can see, touch, or feel, because then people outside the room cannot see, touch, or feel the same thing, so it provides you this security. Of course, you would say, but my device is not a display. How would I configure devices? And I often hear, oh, I have this small temperature sensor that I want to configure. How many of you have a temperature sensor at home?
Sure.
At home?
Yeah.
Only one exception. But most of the time you have devices which are more powerful, something like this. By the way, is your temperature sensor Wi-Fi connected?
No.
No. Okay. So
It's called a thermostat.
you deployed your thermostat yourself, or the building company deployed? See, that's a totally different use case. So we are targeting devices that you go and buy and install yourself, not the housing management company, not this hotel. So I'm not installing the light bulbs in this hotel. That's a completely different scenario. That was the initial part of my talk, is that those are completely different from things that I deploy at house myself. And I would actually argue that those are more vulnerable that I deploy myself at house. So if you look at Mirai botnet, this Mirai botnet was actually caused by home routers and home cameras, not actually by most of the enterprise devices. So you would say, how do I configure my Chromecast? It doesn't have anything to show me a QR code. Well, Chromecast already uses something even more cooler, which is maybe bad for your dogs, I think, but it uses ultrasonic pulses, so it already has this out-of-band message. So the idea again here is that people outside the room cannot hear the ultrasound messages, so it provides the security because whoever is in the room can only hear those messages. And you would ask, how about the Amazon Dash button? Even that doesn't have a display to show a QR code or a camera to which I can show a QR code. Again, this Amazon Dash button already comes with Bluetooth, which again provides you this opportunity of sending an out-of-band message. And you would say, well, that's an additional cost. It is an additional cost, but if you want security, if you want dynamic codes and keys, you have to invest something to get that. Now coming to more technical details of the EAP NOOB protocol, so it does this initial exchange, which is elliptic curve Diffie-Hellman, so it runs elliptic curve Diffie-Hellman over EAP, and the idea is that you can, the idea of Diffie-Hellman is that you don't need to have any pre-established certificates or keys. It allows you to register new devices. So I can actually do Diffie-Hellman with all of you in the room. Of course, it's not secure because anyone else in the room can also see when I do a Diffie-Hellman exchange with all of you, and that's why we have this out-of-band step where the user confirms, yes, this is the right device that I want to connect to my account on the cloud. And that's where you either scan a QR code, you tap NFC, and things like that. But the idea is that you don't things that we did for EAP NOOB. You would ask who runs the cloud. We don't care. It could be the manufacturer, it could be you, it could be some open source community, but that's why we have this possibility that even if the manufacturer runs out of business, you can still continue to use your devices. And I have been asked this question before that, well, if the manufacturer runs out of business, who will run this cloud service? Because who would have the motivation to provide such a service? And I have two examples where people have this open source community and they have been using it for devices which are no longer supported by their manufacturers. So one is routers. If you know OpenWRT, a lot of routers do use DWRT, but if you don't want to use this, you can use your own firmware on them, and it's OpenWRT. The other example is Android. So if you have heard about CyanogenMod, you could actually custom build your own ROM onto the phone. So the idea here is that if the manufacturer wants to use it, if he wants to run the cloud service and connect devices and associate with the user account, sure, that's perfect. But if he for some reason is not motivated enough, so think of startups that are selling products on Kickstarter and running Indiegogo campaigns, or some other companies which are not motivated to run their own servers, well, then you can use some other cloud service because this provides you the flexibility of using basically any server you wish to use. And there is some more technical details of how do you get routed to the right server. So of course your access point needs to point to the right server where you have your user account, and that's something called a network access identifier. I will skip the details. The idea is that you can pick your cloud service and then all your IoT devices would be authenticated with that cloud service, which is independent of the manufacturer. Some more security details, so we don't only rely on the confidentiality of the out-of-band channel. So some security people ask me, if it's a QR code, I could be standing behind you and I could scan the QR code before you actually scan the QR code. Well, it would not help, so we have actually thought this through in quite much detail. We don't only rely on the confidentiality of the out-of-band channel, but also on the integrity of the out-of-band channel. So even if you are this invasive attacker who tries to scan the QR code before I can, you won't be able to successfully use my device. Of course, we use something which is called message authentication codes, or MACs, to authenticate the Diffie-Hellman key exchange. It should either protect secrecy or integrity, so we have double protection. Failure of one does not cause complete loss of security. And as good researchers, you should always think of who is going to deploy this protocol and why. It's not enough that I have written this protocol and I have written this RFC. Why would someone actually deploy it? And what is the cost of deployment? If I have to change all the devices, all the routers, and all the servers, the threshold for doing that is much higher. So I'm not saying it would never happen. We have seen examples of that, but the barrier becomes higher. So EAP download, verify the firmware, and install it. Whereas what I would like to see is something like this, where all the software updates come to my server, and I get a push notification that, hey, your printer has a critical security update, do you want to install it now? And then I, as a user, decide when this update gets pushed. So this is where, again, EAP NOOB can help, because now your devices are connected to this cloud service. You can also provide additional features like software updates. Finally, one example of how this can help with Mirai is to control misbehaving devices. So if your device tries to connect to some server that it should not connect to, and this is somewhere I think even Mud can help, if what Elliot had been talking about at the last connections event is this manufacturer usage description. But the idea here is that if the device tries to connect to some server which it shouldn't, you can receive a notification on your phone or on your service, and you can decide to block it and not allow it to connect to that service. So this could really help with something like Mirai. I had to say this, so technical part of my presentation is more or less over. If you want to study security in Finland, come and talk to me. There is currently a master's program that pays for your travel, tuition, living, pretty much everything. You actually end up saving money. I won't go into the details, but I had to say this. We also have other funding possibilities if you want to come as a visiting researcher, if you want to do an internship. Come and talk to me. I'm here today and tomorrow. But before I finish, because after my presentation there is the panel, I thought I should leave some questions that you should care to ask. So security is often used as an excuse to log in. So this is how you see Apple HomeKit and Google Nest and so on. Well, because of security, we don't want to talk to anyone else, and we want to lock you down. So think about that. Do you really want to be locked into by the vendor of the device, and what happens when the vendor runs out of business? So vendor lock-in is a big challenge that needs to be solved. And then static codes. So of course people say that my device will come with a printed QR code, or my device will come with a printed serial number and a key that I would use. I think static codes are as bad for humanity as global warming. So, I mean, really, like if the QR code gets scratched and you can never bootstrap the device again, that's so bad design. And I can give you another example of where this has failed and people have learned their lesson. So if you are old enough to use a Windows XP system, you could look under your laptop and you would see the Windows XP key. But you don't do that anymore with Windows 10 or Windows 9. And the reason was anybody else could see the key. So if I come and I have access to your laptop, I can take the Windows key and then start using it. And what happens when I sell the device? I could sell you a new laptop which has Windows, but I could have already taken away the Windows key. That's why I think static codes are bad, and we should not do that, even if it means it's cheaper. Doing this out-of-band messages with QR codes that are shown on a display or camera, or doing NFC does incur an additional cost, but that is a cost that you should be willing to pay for if you care about security and privacy. Next is this app nightmare, what I would call. I have one app for this and one app for that, and now I need one app for all my IoT devices. Well, maybe for some of them I can live with it. So of course Amazon would want people to use their app, and Nest would want people to use their app. But if my connected toothbrush has its own app, if my Wi-Fi ring scale has its own app, I think that's a nightmare that's just waiting to explode. So think about those things. That's some consideration that went into EAP NOOB. So all the out-of-band messages are simple URLs. You can open them in a browser. We don't do any customized things that require you to download yet another app. How about privacy? Do you care about privacy? That's a question you should be willing to ask. Do you want the manufacturer to know every time you bootstrap a device? When you take the device from your home and now you bootstrap it at your office, do you want the manufacturer to know about this? If it's a $5 device and you have to add another $5 to do that, I accept that's a big cost. But that provides you much better security than having a printed QR code on the device. I mean,
Okay.
you pay a price for security. It's like if I go for organ transplant, I don't ask for the cheapest organ out there. I ask for what I don't say, oh, give me a hand that meets the basic hand functionality, right? So you have to pay that cost. If you want to do this, you want to have privacy, if you want to have security, if you want the device to work even after your QR code gets destroyed, you would have to pay that price. I accept that. That's a big cost, yes.
Or is it possible to, for example, to interface with your laptop or something
Sure,
like that?
yes,
right?
yes.
That-
You could do it over USB, you could do it over SD card, you could do, as long as it's out of band, it's something that involves the user. Because that's the most important security critical step where the user says, yes, I approve that this is the right device and this is the right server that should be talking to each other.
Okay, thank you.
Thank you, Mohit. That was a wonderful presentation. So a quick question here. Our Ericsson devices. By the way, I'm from Ericsson. So welcome. Thank you. Yeah. So are we planning to support this, or our devices are already on the way of supporting this? No.
We don't make IoT devices.
No, I know that. I'm saying.
I'm hoping. We don't have any devices shipping yet. It's not even a RFC yet. But if there is interest, no, I'm hoping. This is still work in progress. So the open source code is still work in progress.
Okay.
I'm hoping that some devices would soon
I've
start.
seen a couple of articles from research blog on this. Yeah.
There was actually even coverage by the registrar about this. I didn't show it in the slide, so it's not just Ericsson that is talking about it. There are others who have been talking about this, but it's work in progress. Research is a slow slog.
Yeah. Thank you. Yeah.
No question, just a comment. My name is Vinayak. I work with a company called Zoomka. So basically, maybe this is a thing that we can discuss in the panel. Is who is one of the questions that have not been answered is who is responsible for security. I mean, if you see, Mohit mentioned that the Mirai botnet attack. So who should be protecting the victim under attack? In the case of Mirai, it was like DIN, and hence like Twitter and everyone else. Is it the ISP? Is it the manufacturer? Is the user responsible? Should this be regulated by law? Because then there is a legal heft behind it. So these are all questions that have not been answered, and there are various solutions that can be implemented at ISP level, at the device level. Make the user, educate the user, but again, as multiple speakers have pointed out, this is not like a solved problem. Just wanted to point that out.
Yeah, bootstrapping security is still an open problem. There are many solutions, as even previous speakers alluded to. I just wanted to show this article. If you're serious about IoT gadgets, you might as well start getting serious with Radius and EAP. So this was an article based on my draft, and happy to say that it says my name and says my affiliation, so very proud of this work, and I'm hoping that it will get popular over time.
So you were saying about that for 100 of devices we cannot have hundreds of apps. So we need one app, like you were saying. But still, like Alexa is there or Google Home is there. So one app is there which can control devices from multiple manufacturers. So why do you looking for a new?
So my idea is not to replace Amazon. I would be stupid if I try to do that. I think Amazon will still have their app. Amazon will still have users on their platform, and they would still use their own app for bootstrapping their devices, which is fine. So would Nest, so would Google. But I'm also worried about devices that you buy from Kickstarter, which is a startup which is there for 6 months and is no longer existing. Or if there is a manufacturer in China who doesn't even want to run servers, right? They can then use some generic cloud service rather than building their own apps and building their own cloud service. So I'm not replacing all those cloud services that are out there. I'm saying manufacturers that have the capability and have the interest in running apps and servers can do that, can keep control of their devices. But we also need to be aware of the cases where they are either not motivated or not capable of doing that, and how do we support of them.
But most of the devices now, they look for that I am Alexa certified, I am Google Home certified. They can do it at manufacturing level itself.
That's fine. You can still use EAP NOOB. You can still get better security than doing what they do right now.
And then you were talking about the life cycle, that if they do not support, you can go for like open source. And you gave an example of like cyanogen mode, that if you don't, your Samsung is not giving support for Android, you can switch to cyanogen mode. But that is not secure. You would have seen any custom ROM, you can see the warning that I am not responsible for your brick device. If you point your fingers towards me, I will laugh at you.
That is true. If I root my Android phone and install Cyanogen mode, I no longer have warranty. But I think I would only do that once the manufacturer stops supporting the device, or if I have specific reason for not trusting it. And it is a big challenge. I'm not saying everyone can root their Android phones and install Cyanogen mod. So it's not as easy as saying, oh, just replace Android with Cyanogen mod. It would require several steps. And it's not clear how the average users would do that. But the point I wanted to make here is that this protocol allows you to do that. It doesn't prevent you from doing something like that.
But again, it will come back to the first question that everybody is not a CS doc. They don't have a CS.
We are working to make it simpler. So we are taking steps. Neither is 802.1x enterprise security. I mean, an average home user doesn't know what is EAP or radius. That is very true. It will take time. It won't happen overnight. But the point is, we want to get rid of having the same secret for 100 devices on the network.
Hey Mohit, great presentation. I just have actually one question about Noob, which is, what's the order of operations? That is to say, do I have to do this login step in the middle of the EAP transaction, or does it happen in advance?
Based on how you run your server, you could do it until 1 year later, but your device won't have connectivity till then.
Well, right. So, I mean, how do you handle radius timeouts is really what I'm getting at.
So what we have done is that if you are installing tens of devices, you can go and scan 10 of them at the same time and then send them to the server at, let's say, 2 hours, 3 hours later. But we haven't seen a use case where we envision that things would be sent to the server years later.
Thanks.
Okay, thank you.
Thanks, Mohit.